In this video, I want to talk to you about the natural food component carbohydrates. It's really important when we're looking at carbohydrates that we realise that there's two different forms of carbohydrate. There's our simple sugars, which is a monosaccharide, and it's a simple sugar, okay? And the other one that we need to look at is starch, which is a polysaccharide, so it's a complex carbohydrate. And the reason why we need to separate these two carbohydrates out is because they've got really different properties and they behave in different ways when we process them, so that the end result is different because the chemical and physical properties are changing in different ways. So we know that sugar is a simple carbohydrate, so we know it's sweet and we know it dissolves in water or in a liquid. We know starch is not sweet and it doesn't dissolve in water. Okay, so I'm going to look at the two of them differently, okay? But the first one I want to look at is starch, okay? So that is, if we have a look at our table here, starch is our natural food component. And then we need to look at the ingredients that we find starch in. Now, the two most common is flour, and that's any type of flour. So it doesn't have to be wheat flour. It could be corn flour, rice flour, or any of the other alternatives that we use. They all have starch in them. But what is really important here is that you need to know that they have different amounts of starch. And we had a question last week about this. Why does the different types of flour produce products that are different? And it's because of the amount of starch in them. Also, some vegetables are very starchy as well. That means they have a lot of starch in them, and the most obvious one is potatoes, but also things like corn, sweet potato, they all have some starch in them. And it's important that sometimes when you're processing these vegetables that they will have similar reactions to flour. So you know that when you cook potato in water, it goes a little bit sort of gluey around the potato. That's because we've got the process of gelatinization happening. Now, if we look at our starch, it's really important when we're looking at the reactions that happen is that we look at what are the conditions that are taking place at that time. So depending on whether the heat that we're applying to it is dry or wet, will change the reaction that's happening. So we're going to look at gelatinization first, and I'm going to try and explain that to you in a little bit more detail. So when we have starch in a liquid, at first we have our liquid and we've got our water, and the starch will just be floating in that liquid. And this is a cold liquid, and it just floats in solution, but it doesn't dissolve, okay? And then we add some heat, and what the heat does, it starts breaking down the cell wall of the starch, and that enables the water to be absorbed. So we'll start seeing these starch granules, they'll start getting bigger because they're absorbing the water. So we have something that looks a little bit like that. Then when we continue heating, these starch granules will get so much water absorbed into them that they'll become really swollen and the cell wall can no longer contain it and it will burst. When that bursts, that releases the starch granules into the liquid, and we start getting this microscopic mesh formation happening, and that holds the water in place. And then what we get happening is a gel. So it thickens the water. So when we look at our process with wet heat, we'll see the word gelatinization. So if you have a look at the first three letters of that, it's a gel, and that's the easiest way of remembering what's happening there, is that the liquid is trapped inside the starch granules that are burst out of the cell wall. Okay, the next process we need to look at when we're looking at our starches is what happens to starches when we subject them to dry heat. So when we've got our starch molecules and they have dry heat, the starch granules actually break down into dextrins. Okay, so these are much shorter chains, and one of the side effects is that it goes a golden colour, and it's easier to digest when we eat them. So some examples of the cooking methods are baking, grilling and toasting. So you'll notice that when you put starch products in the oven, they'll go a nice golden brown, or when we put bread in the toaster, it goes brown, or when we're grilling some bread under the grill. So it's the dry heat that causes the dextrin, the starch to break down into dextrin, and this process is called dextrinization. Okay? So it's very different to the wet heat, where the starch molecules absorb the water. The heat is actually breaking the starch molecules down into dextrins, which is much preferred method of absorption into the body. Okay, now that we've finished talking about starches, I want to talk about some simple sugars. Okay, now remember these are sweet and dissolve in a liquid. So we have to go back to our table and we have a look. We can see that we've got the natural food component is sugar. Some food examples are things like table sugar or fruits or glucose. Sometimes a recipe will require liquid glucose as one of the ingredients. And the two reactions that we're really looking at here are our caramelization and our aeration. Now, caramelization happens when we have a simple sugar and we're heating it up. Usually we put the sugar in a pan, and we can either do it without any liquid or we add a small amount of liquid, and we're looking for a particular reaction, and it's a browning reaction. So what happens is that the sugar begins to decompose, which means break down, okay, when it's exposed to those really high temperatures. And what happens there is that it goes brown. Now, it's a really tricky process because we want it to go brown, but we don't want it to develop too much, because then what happens is that the sweet properties of sugar disappear and it becomes really bitter. Okay? Some examples of that is like when we caramelize sugar, but also such as if we're doing sweet, we're cooking something sweet in the oven with dry heat, often we can get a caramelization process happening, or things like roasting coffee beans. There is a caramelized reaction happening there. The other one that I want to have a look at is aeration. And this is really important with the creaming process when we're using sugar, okay? It's one of the ways we can incorporate air into a product, okay? And this is the process here, creaming. So often you'll see a recipe that requires you to cream butter and sugar together. And what you're actually doing is you're having a look at your sugar. So you've got your sugar granules like this, okay? And if you have a look at sugar under a microscope, they've actually got a whole lot of little sharp little edges. And by beating the butter or fat into the sugar, we're actually wrapping that around the sugar, and all these little sharp edges will create little air pockets. And it's those air pockets that aerate the product. okay? Because we know that when we put air into a hot oven, the air expands and it causes a rising effect. So it's really important because the sugar has all these sharp little edges that it traps air into the product, and that's how we get an aeration reaction happening with simple sugars and fat.